Hey everyone, welcome back for another video. So we're going to be talking about how steel is classified, and we're going to talk a little bit more about other materials, other metals. Um, this is all going to be very important because as welders and fabricators, of course, the main material that we're working with is metal, more commonly carbon steel, sometimes stainless steel, aluminum, so on and so forth. So whenever we're picking a certain metal that we're going to be, preparing, cutting, welding, we need to be able to know, or at least know how to find out what type of metal it is in order to find out the proper procedures in which to prepare it, cut it out, and then weld it so that way we can ensure structural integrity and just, make sure that what we're doing is correct. So let's talk about carbon steel or just steel in general. So when we're talking about steel as a metal, steel is not just a single element. Steel is just not one thing. It's actually a mixture of two different elements. Well, two main different elements. They are iron, which can be seen right here, and then carbon right down here. So when you think of carbon, a really good example of carbon can be coal, charcoal, like the charcoal you use in your barbecue grill. These are the two main ingredients, iron and carbon. Now there are additional elements that are added to it in order to make it, maybe stronger, more corrosion resistant, things like of that nature, but those are added in small amounts. So when we talk about steel, steel is used in so many different applications. It's almost crazy that anywhere you look nowadays, you could see something that's made out of material. You can look at the list there of some items that are made of steel, and then you can also look at some of the pictures. So, some of the amusement park rides you go on, parts of infrastructure like telephone lines or telephone poles. Some of them aren't always made out of wood. And then you have power lines, and then the structures that hold the power lines. You have pipelines that can carry things like natural gas or even petroleum products. Heck, even the grates that are in your barbecue. We can look at, parts in your vehicles, parts of your computers, and of course, the tools that we use in our garage and like auto shops and things like that. There are so many things that are made out of steel. When we start looking at the alloying elements, these are just a few things that are added to steel to change some of the physical properties. And so when I'm talking about physical properties, this is what I'm talking about right here. So how hard is the steel? How strong is the steel? The hardenability. So this is similar to hardness, but hardenability is something that we can manipulate. So with all the different elements that are in the steel, it's going to affect how we can take a steel that is soft and make it harder, or take a steel that has been hardened and make it softer. Okay, and then machinability. So this kind of has like a dual meaning. Machinability is, not just can a machinist work with it and mill it out into the shape or the part that they want, but machinability could also be translated to, how easily can we work the metal with our hands and basic tools. And then deoxidizes, what that means is, which elements that are added are going to help to deoxidize the steel, which is going to, hopefully, depending on how the steel is stored, it's going to prevent it from oxidizing or basically forming rust, things like that. And so here are more of the elements that are added to steel. So this is more of a comprehensive list. In both images, the left column is going to be the list of the alloying elements, and then the column on the right is going to be the effect that they have on steel. So let's just take a few of them. For example, let's take lead. So if you add lead to steel in trace amounts, we're not talking in big amounts here. We're just talking about fractions of a percent, like maybe up to like a couple percent at most. So if we add just a little bit of lead to steel, it's going to affect its machinability. So lead is a lot softer than steel. What it should say here is increase of machinability. And let's say if we add nickel to steel, it's going to increase the toughness and strength of steel. And then let's just go on over to the right. If we add a little bit of copper to steel, it's going to increase its resistance to corrosion, and it's also going to increase its strength. And then if we add something like cobalt to steel, it's going to increase its hardness, and it's also going to make it more wear resistant. So these are all different elements that can be added to steel as the steel is being made. This isn't something that you just slap on a piece of steel after you buy it from the store. This is as these manufacturers are creating the steel, these elements are added to the mixture. Like I was saying in the very beginning, there are many different types of metals out there, and we need to be able to identify what we're working with in order to know that the process that we're going to use to prepare it, cut it out, weld it together, and even finish it, we need to make sure that all of that aligns with the type of metal that we have. With all those different types of elements that can be added to steel, they can actually change what type of steel we have. So, with that being said, there are different types of steel. And I'm not just talking about basically saying there's carbon steel and stainless steel. I mean that there are different, I guess you can say, classifications or grades of carbon steel. And there's two different systems that can be used to classify them. So this is the first system of classification. This isn't the first one that came out. I'm just kind of saying that this is the first one we're going to talk about. So it was developed by two different organizations, the American Iron and Steel Institute, or the AISI, and the Society of Automotive Engineers, or the SAE. So both of them came together to create a system that would classify steel. And it's pretty simple at its most basic form. It just uses a 4-digit number code to classify steel. That's going to look something like this. Now, there are no numbers here, obviously. These are just placeholders. But just like with our welding electrodes, where each number on the electrode tells us something about the electrode, with the 4-digit classification system with AISI and SAE, the numbers, or the places that the numbers fall under, are going to tell you something about that steel. So let's go ahead and look at that. If we have 4 digits, we can split that in half. The first two numbers are going to tell us overall what type of steel we're working with. Now the last two numbers are going to give us a general idea of the amount of carbon that's in the steel. So remember, I had told you that the two main elements in steel are iron and carbon. So not only will the type of alloying elements being added to the steel, not only are those going to change what type of steel we're working with, but the amount of carbon that's added to steel is going to change what type of steel we're using. But don't worry, it doesn't get very complicated. It's going to be pretty easy. But I do want to tell you, or just recap, that the first two numbers tell you generally what class the steel falls under. And then the last two numbers tell you how much carbon is in the steel. It runs off of a percentage by volume. So if you were to see an example, actually, next slide has some examples here. So 1020 steel. This is just one example I'm going to give you. 1020, so 1020. This is one example. The first two numbers, 1 and 0, tell us that we're just working with regular carbon steel. Now the next two numbers, 2 and 0, a lot of people will think that, well, that means 20% carbon. But actually, it's almost like you're putting a decimal period in between the 0 and the 2. The 20 means that there's 0.2% carbon in that steel. Now, if we take 1095 steel, again, the 1 and the 0 tell us that it's just carbon steel, and the 95 tells us that there's approximately 0.95% carbon in that chunk of steel by volume. Now, if we move on and we say you have something like 4130 steel, the 4 and 1, or 41, tells us that we're working with chromium molybdenum steel. And the 30 tells us that there's 0.3% carbon. So then with the 5130, 51 tells us that it's chromium steel. 30 tells us that there's 0.3% carbon. And with 6120, the 61 tells us it's chromium vanadium steel. And the 20 tells us that there's 0.2%. Now, you might be wondering, how do I know about the first two numbers? How do I know what the numbers are telling me about the classification of steel? What type of steel? Well, there's a chart for that. And this is the basic chart. If we look over both images, the column on the left is going to be the numeral designation for the steel. And then the column on the right is going to be the major element. Or it's the element with the greatest presence in steel. So if we look at the 10 series steel, remember our first examples, 1020 and 1095. 10 is basically just carbon steel. That's it, just carbon steel. And then the last two numbers tell us the carbon content. And as we start moving up, 13 series of steel, manganese is the alloying element that has the greatest presence. We move on to 23 and 25. Nickel becomes the highest percentage alloying element. The 31, 33, and 303 series is just nickel chromium. And on and on and on and on. So basically, you're going to have 4 digits, and in some cases 5. If you ever have a case where there's 5 digits, the last 2 is always the carbon content. So that means that the first 3 tell you what type of steel it is. Now let's take a look at the second classification. So this system of classification was created by ASTM International, which was formerly known as the American Society for Testing and Materials. So what they do is they kind of stray away from just using numeral digits. They use a letter and a series of numbers to identify steel or any other material, because they also classify things like stainless steel, copper, aluminum, and so forth. But I won't go too far into the other materials. Let's just keep it simple and just talk about carbon steel for a moment. So here are some examples of steel classifications for ASTM. So as you can see, what comes first is going to be a letter. What comes after is going to be a series of numbers. Now, A36 is a very general, well, I won't say general, but it's a very commonly used steel in the structural industry. So if you think about buildings, A36 is, very common. Then we have A48, which is specifications for gray iron castings. We have A131, which is for structural steel for ships. And then we have A368, which is stainless steel for wire strands. Now, these are just randomly picked examples out of a list of, like almost 1,000 different specifications. I would give you a chart example like I did with the AISI and SAE classifications, but in order to show you the entire list, I probably have to make this like a 45-minute PowerPoint, and I really don't want to do that to any of you. So like I said, there are, really close to like 1,000 different classifications under ASTM. In order to see the entire list, you would have to go to their website and look that stuff up. The difference between this system and the first method that I was telling you about was the first method really classifies the steel by the major alloying element and by the carbon content. ASTM classifies steel and other metals by its physical properties. So like its tensile strength, its yield strength, and other chemical composition. So where it's kind of similar to the first method where they talk about alloying elements, this method it centers more around the strength of the material. So if we look at just a sample chart, so this is, we're going to look at A36. So this is A36 steel. The top image is the chemical composition. And then the bottom one is the mechanical properties, or like what I was saying, like the strength of steel. So if you wanted to know what type of steel is considered A36, you would have to look this up in a book of standards from ASTM, and it's basically going to tell you that in order for this type of steel to be considered ASTM A36, it has to meet these requirements. So if you start looking at the different alloying elements, okay, so depending on how thick it is, it needs to meet these requirements for the elements. So we have carbon, magnesium, I believe, silicon, phosphorus, so on and so forth. I believe that's sulfur, Cr. I know that's not chromium. I can't remember what that is off the top of my head. And then you have nickel and molybdenum. If it falls within this percentage of those elements under that thickness, then it can be considered A36. Now, in addition to meeting the criteria for these alloying elements, it also needs to meet the requirements for these strengths. A36, the yield strength, has to be 36 KSI or 36,000 PSI. The tensile strength has to be 58 to 80 KSI. And so this is how we can determine exactly what ASTM means by when it's classifying steel as A36 or some other number letter designation. All we have to do is just look it up, and it's going to tell us exactly what the characteristics are. How do we identify a steel? How do we know where to look at these or look for these designations? Honestly, the easiest place to look is the packing slip. So whenever your place of employment receives metal from a manufacturer or a distributor, easiest place to check is the packing slip. The packing slip will almost always tell you what type of material it is, and it'll tell you usually both the AISI SAE classification, and it'll tell you the ASTM classification. Sometimes they're stamped on the material itself. Then there's also a spark test that you can do where you can just kind of take a grinder and, kind of grind the edge a little bit and take a look at the sparks that are coming off of it. The sparks will tell you, they'll give you a good idea what type of metal it is. You can always test it with a magnet, and then there's the scratch test. So you can use various tests to kind of narrow down what type of metal you're working with. And so here are just a couple examples. So here there's a shipping label on the material itself, and it will tell you, it should tell you what it is. You can use a magnet to test metal to see if it's magnetic. Now here's where you got to be careful, because there are some stainless steels that are magnetic. There are some stainless steels that are not magnetic. Okay, so here I've got various pieces of metal, and I've also got a magnet. So this is going to be for the magnetic test. And to show you that this magnet works, I'm going to take this pipe. I'm going to take this pipe that I know is steel, and I'm going to take this magnet, and I'm going to pick the pipe up. So this is just to show you that the magnet indeed works. So I'm going to use this magnet to test these different metals here. But it's important to note that a magnet is only going to be attracted to metals that contain iron.
Iron is what gives steel its magnetic properties. It also gives stainless steel its magnetic properties. But it's also important to note that some stainless steels are not magnetic. I'm not going to go too far into it. We're just going to kind of focus on carbon steel for this demonstration. And then also, in addition to the magnetic test, another way to tell if a metal contains iron or not is whether or not it rusts. So if you leave metal outside and it's cold or it's rainy and you start to notice that it's starting to rust or what is technically called oxidizing, then you know that it contains some amount of iron. Still, it could be stainless steel, it could be mild steel. Not really sure. We have to do further testing, but it's a way to narrow down exactly what you have. So let's go ahead and start with the first piece. So this piece is relatively shiny, it's very lightweight, and it creates sort of a dull sound when you tap it against something that is steel. Alright, so let's see if the magnet's going to be able to pick it up. So the magnet does not pick it up, so we can go ahead and rule it out as being carbon steel. And now it could be stainless steel, it could be something else. I know what it is, but I'm not going to give you the answer just yet. I'm going to wait until we go and test the other pieces of metal first. So now let's take the second piece. It's a little more mirror finished, sort of. It's shinier. It's a little heavier too. All right, so let's go ahead and test it with the magnet. So I'm feeling a little bit of a pull. It's not picking up the piece of metal, but I feel like there's some pull. I'm not sure if it's the steel tabletop underneath, so I'm going to go ahead and put it in my hand and then test it while I'm holding it. So there's a little bit of pull still, so there's probably a little bit of iron in this. But there's not enough there's not enough iron in this to make it carbon steel, so that rules out carbon steel and kind of gives us the thought that maybe this could be stainless steel. Now let's move on to the third piece. Now, this third piece of metal is obviously smaller than the first two. And it's definitely lighter than the second plate, but for being this small size, it's about as heavy as the first plate. And let's go ahead and test that with a magnet. Okay, so it definitely picks it up, so we know that there is definitely iron in this. And so I feel confident at this point, without a doubt, that this is definitely carbon steel. And let's go ahead and move on to this fourth piece of metal. And I see a little bit of rust on there, so that tells me that it probably has iron in it, or it was underneath something that was rusting and it sort of picked it up. But let's go ahead and take the magnet to it. So the magnet definitely latches on. It definitely wants to pick it up, but I think that this piece of metal is too heavy for the magnet to pick up. So I think it's just a weight thing here. So there's definitely iron in this. It's just too heavy for the magnet to pick up. It could be carbon steel, it could be something else. But because of the use that it's intended for and the texture of it, it could also, tell you that this might be cast iron. And so we take this last piece of metal here. It's definitely a different color than the rest. I polished one part of it. That way you can see its true color. Looks like copper. Could be copper. We don't quite know, but we're going to go ahead and test it anyways. And nothing whatsoever. So we can definitely rule that out as not being carbon steel. So, are you ready to hear the answers and find out what's what? This plate right here, this first one, this is aluminum. So the first clue in telling that this was non-steel and could be aluminum is, it's non-magnetic, and then also when you tap it with something that is steel, it has sort of a dull sound to it. And then also when you get more experience working with materials, you can just sort of look at it, see the scratches in it. You can look at the cuts on the edges, and you can kind of get more information like that to tell what type of metal it is. And you can also determine what type of metal you have by using what's called a scratch test. Aluminum is known to be very soft, so if you take a metal that you know 100% what it is and you try to scratch aluminum, if you scratch the surface of the material, it tells you that it's something softer than what you currently have, and so therefore you are not holding the same material in both hands. Now this one, the second plate, this is stainless steel. And so stainless steel is typically harder than regular carbon steel. So if I were to take this smaller piece of carbon steel and try to scratch the surface, you'll notice that I'm actually not able to scratch it at all. So, and just the opposite, if you were to take stainless steel and try to scratch steel, you would actually be able to put some marks on the surface of carbon steel. And the third sheet, we've kind of already established that it's carbon steel. And then the fourth piece of metal, the weight is actually cast iron. And the big giveaway here is not only that it's magnetic, but the texture of it. And I don't want to actually break this, but if I were to break this apart, you'd be able to look at the grain structure inside and see that it's very coarse. It's like open and coarse, and that's a key characteristic of cast iron. And this last piece of metal, this is actually copper. And you can see that it's two-tone. I took a wire wheel on a grinder just to polish this up, just to show you what it actually looks like. The more dull looking area is what copper looks like after it kind of starts to oxidize and pick up impurities. It also looks like it was kind of used to cool off welding parts. You can see some arcs on it. But yeah, this is copper.
So using a magnet to narrow down what type of metal you're working with can be useful to narrow it down to just a couple different types of steel. And then you have to do further testing just to be sure of what you have. And this is where you can take an angle grinder, grind a little bit, pay attention to the color and the shape, the size of the sparks to give you a better idea of just what kind of metal you're working with. So here are a series of images. Each one is a different piece of metal that is being grinded up against a grinding wheel. So this is a pedestal grinder. So look at all of these. Look at the shapes of the sparks. Look at the volume of sparks. Look at the trail of the sparks. Look to see how bright they are. Look at the color. Just look at all the different characteristics that makes each set of sparks, and then try to guess what metal corresponds to which letter. So here are the answers. So A was low carbon steel. So this is basically anything that's 0.2% carbon and below. B is medium carbon steel. C is high carbon steel, chromoly steel, manganese steel, cast iron, stainless steel, and titanium. So I'll kind of sit here for a minute, let you read all of those. And then I'll go back so you can see them. Back again. Okay. Now here are some other characteristics of the spark test that you should be looking for. When it looks like this, these are called like the streams. So when the sparks are streaming out. And when they're just looking like this, these are called the shafts of the sparks. When the very ends of the spark streams seem to be kind of fraying out, or they almost look like wheat, we call that fork or forking. So the sparks are forking out. All right, and then like a bud break arrow kind of look, and then sprigs. So it's almost like forking, but it's much more like exaggerated, accentuated. And then dashes. Okay, so the sparks are dashing. And then appendages. So it's kind of like it goes out, stops, and drops down. So those are the appendages. So when we jump back to the previous line and we're talking about streams, sprigs, bursts, branching, stuff like that, these are what we're talking about right here. So why does all this information matter? Again, remember, working with different material is going to change in how we prepare a material. It's going to change how we weld the material, what we weld it with. Some metals will require heat treatments. And we always want to make sure that we're using the right materials for the job. Otherwise, we could be risking injury to others, damage to equipment or materials, things of that nature. So we always want to make sure that we're doing the right thing and that we're working with the right stuff. And that's it. Thank you for watching.